Let's look at an example of Newton's universal law of gravitation. But first, let's review the law. In the law, we have a gravitational force of attraction, which is F. That is equal to this gravitational constant, this universal gravitational constant G, which has a value of 6.67 times 10 to the minus 11th Newton meters squared. And notice it says kilogram to the minus 2. When we do this, what we mean here is we mean Newton times meter squared, and then kilogram to the minus 2 means divide by, and put the kilogram down there with the squared. The minus 2 means that the kilogram squared is in the denominator. So that's what we mean there by Newton meter squared per kilogram squared. M1 and M2 are the masses in the equation, and units are given in kilograms, and R needs to be in units of meter, and it's the distance that's between M1 and M2. So basically, you've got some object M1, and you've got another object M2, and these two are separated from the center of one to the center of the other by a distance r. Let's look at an example. It's a basic example. So we're just going to calculate it out. We're given two masses, M1 and M2 are 2 kilograms, and they're 2 meters apart. So we have, that could be any shape. This one's 2 kilograms, M1's 2 kilograms, M2's 2 kilograms, and the distance is 2 meters apart. We want to find the gravitational force of attraction. So we have hints. Express your numeric answer. That means no units, just numeric, just the number, in 2 decimal places. For example, 12, 1.2, 0.12, or 0.012. You only count the zeros to the right of the number, and since there's only 2 numbers here, it's still 2 decimal places in 0.012. So let's look at our forces. Our force is what we're trying to calculate, and that is equal to G, which is 6.67 times 10 to the minus 11th Newton meter squared per kilogram squared, times M1 times M2, both are 2 kilograms, and then divide that by R squared, so it's 2 meters. You put R in the parentheses, and then you square on the outside of it. So now we have to take 6.67 times 10 to the minus 11th, multiply it by 2, and divide by 2 squared. So let's go ahead and do that. Let's bring up our Google calculator, and I cleared it out. So we're going to type in 6.67, and then you look for the EXP key, and we want to type in minus 11, and that's our gravitational constant. We said we want to multiply by the mass of one, which is 2 kilograms, multiply by the other one, which is 2 kilograms, and I'm going to hit equal sign because that's everything that's on the top part of the division symbol. Then we're going to divide by, and I'm going to put a parentheses in. So this is the denominator part, which is r squared. So we need to put a 2x to the y and square in it, close it up, and hit equals. And this is our value, 6.67 times 10 to the minus 11th. So we need to go back to our paper and type that in. So we have 6.67 times 10 to the minus 11th. And now we need to multiply and divide out our units. So we have a meter squared, and this meter squared is a meter squared. So we can cross that out. We have a kilogram and a kilogram, which is a kilogram squared, and divide that out with kilogram squared. And we are left with newtons as our answer. So our force is 6.67 newtons, 6.67 times 10 to the minus 11th newtons, and it's attractive. So we're going to put in our box, and I'm just going to put a big G here. So it's the universal gravitational force. Now, one thing I wanted to point out is we can easily look at this. We didn't need to multiply it out because we have 2 times 2, which is 4, divided by 2 squared is 4. So we can automatically eliminate the 2, and the 2 squared as well. And our answer automatically pops out as 6.67 times 10 to the minus 11th newtons.